Hello and welcome to Chapter 11, Section 8. Today we're multiplying and dividing radicals. So what we're saying essentially is that root A times root B is root A times B and vice versa. So let's do a few together just to make sure you're good at this. Root 3 times root 6 is the same as root 3 times 6, and 3 times 6 is root 18. But we know that there's a root in here because this is really 2 times 9, and 9 is a perfect square. So our answer is going to be 3 root 2. 5 root 3 times 5 root 3. Well, 5 times 5 is 25, and root 3 times root 3 is root 9, which is 3. So our answer is 75. 2 root 8x times root 4x is 2 times 8 times 4 is 32x squared. X squared is a perfect square, so we're going to pull that x out here. 32 is really 16 times 2, and this is root 4. So our final answer is going to be 8x root 2. We're combining what we know about multiplying with variables and simplifying radicals. So please pause here, try check it out number 1, and come back when you're done. For 1a, root 5 times root 10 is root 50, which is really 25 times 2, so we're going to pull out that 5. 3 root 7 squared is 9 root 49, and 49 is 7 squared, so we're going to pull that out, and our answer is 63. Root 2m times root 14m is root 28m, and that's got a 4 in it, and that's an m squared's root is m. So we're going to pull m out, we're going to pull that 4 out, and it's 2m root 7. We can use the distributive property when we have an expression with parentheses. So root 2 times 5 plus root 12, we're going to distribute that root 2 to both of them. So we have 5 root 2 plus root 24, and we know this is 4 times 6, so we're going to take that out. So we've got 5 root 2 plus 2 root 6. We're going to distribute this. Root 3 times root 3 is going to be 3 minus root 15. And this is 3 times 5. There's no root in it, so we're stuck with that. Give that a shot. Stop here and try check it out number 2 and come back when you're done. Root 6 times root 8 and root 6 times 3. And 48 is 4 times 12, and 12 is 4 times 3. So we've got 2 4s that we could take out. That gives us 4 root 3 on this side and 3 root 6 on this side, and they don't combine. Root 50 over here and 4 root 15 here. 5 and 3 doesn't change anything, so this stays 4 root 15. 50 is 25 times 2, so we take that 5 out, and we don't have similar roots, so we stop. For question C, when we distribute 7k, we get root 49k, and we take that 7 out to the outside. And here we just end up with 5 root 7k, and they're not the same, so we stop. 5 root 5 distributed gives us negative 20 root 5, which just stays the same, and 30 root 25 here, and that 5 comes out here to multiply together. We could also stick it in factors where we have to multiply and use FOIL. So here, 4 times 3 is 12. 4 times negative root 5 is negative 4 root 5. Root 5 times 3 is positive 3 root 5. And root 5 times negative root 5 is negative root 25. So this becomes negative 5. Negative 4 root 5 plus 3 root 5 is negative root 5, and 12. So that 12 minus 5 is 7, not minus, root 5. That's our final answer. Root 7 minus 5 times root 7 minus 5 when we do FOIL. Root 7 times root 7 is 7. Root 7 times negative 5 is negative 5 root 5, and these two are negative 5 root 5. And negative 5 and negative 5 is positive 25. So 7 minus 10 root 5 plus 25. 25 plus 7 is 32 minus 10 root 5. All right, why don't you give that a try? Pause here, do check it out number 3, and come back when you're done. We combine negative 3 root 3 and 8 root 3 into 5 root 3, and these two into 21. We combined the middle 2 into 18 root 2 and the outer 2 into 83. We combined the middle 2 here to negative 6 root 2 and the outer 2, because root 4 is 2, and we're going to add that to our positive 9 to get this. Our middle 2 becomes negative root 3, and our outer 2 becomes 17. When we get radicals in a fraction, when we simplify, we have to make sure there is no radical in the denominator. So the first thing we're going to do is try and break everything down and simplify everything we can, and that's the last thing we check. So here, there's really no simplification for root 7 and root 2. They're prime numbers, so they're just there. But we can't leave this root 2 here. So we're going to multiply the top and the bottom by the same thing to make sure that this goes away. So now I've got 2 on the bottom, which is just fine, and I've got root 14 on the top, and there are no perfect squares in 14. So we're done. Here I want to simplify this just a little bit. This is 4 times 2n, and we're going to take out that 4 to have a 2 on the outside. So now I'm going to multiply the top and the bottom by 2n. I'm either going to reduce it in the beginning or in the end, it doesn't matter. So if I multiply 2 root 2n by root 2n, I end up with 2 times 2n, which is 4n on the bottom. And I have root 14n on the top. And that's my answer. Why don't you give a couple of these a shot? Pause here and do check it out number 4. Come back when you're done. For 4a, these are both prime numbers. I just multiply the top and the bottom by root 5, and the top ends up with root 65. For b, I wanted to show you the difference between reducing at the front and reducing at the back. Here, I just went ahead and multiplied top and bottom by root 12. And I got 12 on the bottom, but the top is a great big number that I had to factor out. So I did have to factor out that 4 eventually. So when I factored out the 4, that gave me 2 times root 21a over 12. And then the 2 and the 12, I could cross cancel, so I end up with 21a over 6 when I'm done. Here I multiplied the top and the bottom by root 7, which gave me this great big set of numbers. I tried to pull out the perfect squares and put those on the outside, so I have 2 times 2 times 2, which is 8 on the outside, and that leaves me 35 on the inside over 7, and these won't cross cancel, so we're done. Please make sure you ask if you have any questions. Tonight's homework starts on page 843. It's numbers 27 to 66, every third problem. I will see you next time.